what do we got here? We don't need that. Okay, so the first thing I want to do is pull out all of this that's not platform specific. It's sitting in the Windows file. A lot of it doesn't need to be sitting in the Windows file really. So, well, all of this is Windows specific. The Arena initialization, HWind, D3, D11. Okay, so this stuff, yeah, like everything, all of this essentially is not. So I'm just gonna put it here. Probably just of tests. All right. Void run something. I don't know. I mean, I guess this part is really init. Yeah, so this is like init, and so like init, something like that. We call it here. Only honestly, that kind of goes there as well. And then in, okay, so this is fine. That's fine. I mean, input is gonna stay. Okay, all of this UI stuff. Okay, this is rendering, right? Yeah, rendering is gonna stay. Let's move this over here. Okay, all of this will go, yeah, all of this. And goes into something like void run. Okay, so something like that. Run. Okay, so what do we need? Let's see. Context. Input, well. Input comes from here. Although honestly, Arena, Scratch. Alright, well, let's just take all these things. In. What is it? Do I still have it? Yeah. Do we not have import micro UI in here. And we don't. Okay. Import micro UI. Well, actually, yeah, we're not taking that in, we're taking Marina. Oh, are we? Yeah, text is kind of a... Okay, yeah, no, we're not. We're taking this in. And we're doing the initialization here. Because text width and height, yeah, that's kind of a platform specific thing. Because the platform is the thing that's throwing the text. Alright. So now we're not doing this here. We're just taking in an already initialized context. Yeah. Now we still need an arena. And another arena. So new context, arena, sketch, something like that. Okay, so now init kind of works. Run. Well, run clearly needs a lot of the same things. Like mu context. Also needs to know how big the window is within which it's supposed to be running. Yeah, okay, struct state, let's see. So we're gonna need all three of these. So that's passed in from the platform and it's initialized. That's also passed in from the platform. That's also passed in from the platform. And this init, and it might as well put it in here. Well, actually, we can pass a ref and just take an address, right? Yeah. Okay, so these strings, I don't think we're actually using them. So they can go away. Let's move this enum up here. that something I can do? Yeah, seemingly. Okay, so now having to repeat this year-day thing is error-prone, as evidenced by the fact that there is an error here. Like this is result 2022, not 2020. So can we avoid having to repeat these things all the time, everywhere? Hello, chatter? Alright. Maybe. Maybe we can. So what's this problem anyway? You can't pass 2 pointers to it? Well, I disagree. I mean, like, you could dereference, presumably. Can we dereference? Yeah, you can. Which is not actually going to dereference anything, it's still going to be a pointer. But fine, whatever. Can we just have an array of results? Although this run might as well go inside state. And it's really just draw. Width, height. So state state. Yeah. Okay, so solution ID, state. Well, I mean, might as well pull it out. Run is like state draw. Okay, so this is a state.activeSolution. That's just active solution. What's this? Yeah. Okay, well. I mean, I guess we can take in font height. Window width. Window height. Font height. cast int. Yeah, so where is this coming from? Unclear. Oh my god. Okay, I can see why references are not really that good. Because like here we have no choice but to use pointers, and then everything that takes a reference we have to dereference. I mean, I guess we can just copy the arenas in here, but like, yeah, but then we're gonna have 2 copies of arenas lying around in main. That's also not good. Yeah, so only one problem now. What to do with these results? I want to put them into an array. So just have like a solution array solutions. And solution ID, I mean, even solution ID is like, still repeats things like year, day, year, day, year, day. Not ideal. Ideally active solution would just be an index into that. So yeah. And even solution ID wouldn't be necessary. Let's see. So it's an array of things that are all different types. So presumably D has discriminated unions. Like the std variant, there is another std something else. Variant. There's also a some type, which is different from a variant somehow. Struct some type, a tagged union that can hold a single value from any of the specified set of types. Basic usage. Oh my god. Okay, so some type is defined like that. What about a variant? So variant defines, like, allows an infinite set of types, apparently. Okay, so variant. Okay, am I even allowed to use variant with var_c? Let's find out. Import std variant. I think so. Okay, so you define variant A. So it's just, okay. Variant temp variant. So you define it. Is that allowed? That is allowed. Okay. And then you can assign things. To it. Okay. All right. so like temp variant, well, it's an array, right? Array of 2. Temp variant 0 equals, let's say it equals that. Like, it looks like we can do this. Okay, well, let's try it. Solutions 0. That would make it slice. Okay, so then we would have to like know ahead of time how many, which is not, I mean, right now it's 3. Okay, well, let's just do it this way. Year 2022, day 1. Okay, again, that is another repetition. Global input. Arena. Yeah, it seems like it would be better. Oh, actually, we are not allowed to do it. We are not allowed to do it with beta C. Okay, can we use some types with beta C? So that's a defined set. Some type, some type, exclamation mark, and then you just list the types. Struct solution. Well, actually, it's not struct solution, right? It's alias. Alias solution is. Can we do like static import instead and just do this? Some type. Exclamation mark, and then year 2022, day 1 result. So now this is a solution. Module some type isn't a template. Okay. I mean, sure, fine, that works. Oh my god. Okay, so now this solution thing essentially has an enum with this as one of the enum values. Can we do anything with this thing other than no dependency on runtime information? Yeah, see, that's good. Compatibility with beta C, yeah. Okay, so what you can do with it is you can match it. Okay. Can you do anything other than having to match it? Because we have all this input stuff that's although, I mean, input, maybe we can get around having to repeat the name there. Match. Some type. So what is this supposed to be telling me? Just all the operations defined in it. Yeah, match, that's kind of the main one. Okay. Same dimensions. Alias do much. Point 2D, 1.2D to what are you doing here? So there we go. Point 2D, point 3D. Do much. So it just returns these things. Whereas this one matches them like one by one. Oh, I see. Okay, well, maybe. Match exception, yeah, well, not doing that. Okay, might as well wrap everything else in the results. Also, maybe you can avoid more repetition if I just take this and put that in here. Input arena scratch. That doesn't conflict with anything, does it? No. And just make this a constructor. Okay. So year 2022 day 1, that only appears in, well, 7 places. What if 15 places actually? Okay, well, yeah, gotta reduce that. So we don't really need to declare this so much. That's fine. Calories, item counts, sums. Well, I guess slice. We don't need to do this. Well, essentially all of this is just assignments, right? Calories, item counts, sums, elf count. Max sums is already what it's supposed to be. So it's just that. What do we got a problem with? Expression expected. Oh yeah. Okay. 14 places. Well, we have to repeat it here to define the sum type. We kind of have to call it here with the input. Can we access the amount, like solution, Other t value, mangle of, size of, tuple of, string of. I just want the number of elements. Types. Types is some kind of array. Other. T. Value. Op assign, op equals to hash to string destructor. A line of init. Mangle. Size. String tuple. Types. Types length. Like, is that something we can access? Yes. Huh. Yeah, that's good. Where's the key to? There it is. So, can we perhaps just do it this way and then not have to synchronize that manually? Yeah, okay, so that's a little better. While we are at it, might as well do the same here. Oh, I mean, this is just long to result. Okay, so that's one more repetition gone. Yeah, that's fine. So that's day 2. Day 3 is gonna be like that as well. Result. Oh my god. Okay, so all of this goes in. Okay, so struct. And then all 3 of those go into the solution. Two, 3. Wait, is they not capitalized? Yeah. Alright, so now we've got 3 of these. And really I just want to loop over them and just call the corresponding constructor. And I mean, depending on what it is, the input is different. And the arguments could be different as well. Well, I mean, the arguments won't be different. Like that. So this is how it would be done manually. And obviously, like this, having to repeat this and then this is not ideal. Is that loud? No. You have to like unwrap the thing first, so let's think about that. Yeah, we're not really doing this anymore at all. Okay, so this is like looping over the enum to create the buttons. I suppose what it really should do is loop over the types, like solution types, type. Yeah, that's something we can do even. Yes. If active solution, well, can we do type index? Seemingly we can. If active solution equals type index, then to go in. Yeah, that's fine. And draw a button where the button is so that needs to be a string. All member solution ID int. Yeah, so that needs to be a string. So that's just solution types. That's an array, right? So like active solution. No, wait, not active solution. Type index. String of, like it's something like this. And this is just going to be type index. Ah, okay. So this is where we unpack what the solution is. So really, what we're switching on is yeah, I'm just trying to like match what is the basic usage here. Yeah, so I'm just trying to match oh god, what is this? So you do like solutions, active solution, match, exclamation mark, and then that's like a function call, And the function call takes essentially like variable declarations like ref year 2022 day 1 result. Well, I guess sol, oh, it's sol. And then this, so this is like a function, more or less. This is a function. And so that would go in there. That's not going to happen anymore. The other two don't really do anything anyway. Like, we don't really need the scope. Yeah, so the match, so that's like a sort of function call, right? And then it needs to terminate somewhere, which it does here. Okay. Let's test. Wait, this is a closure that needs to be allocated? Well, how about you make it not a closure and just a normal function? The layout row is a closure thing. Well, I mean, is it because it takes in new context? For draw. There's the lambda 9. Well, it's not meant to return anything. What? For a multi-statement function literal. And like that? What? Yeah, that is a function literal. Zero solution types length -1. Solution types length -1 means 0. Okay, that's all fine. No matching handler. Oh. Yeah, we need to define handlers for everything. Well, that's fine. Ref year 2022 day 2. Solution doesn't do anything, and day 3 also doesn't do anything. Do we have commas between them, or what? Okay, so that compiles. Mm-hmm. Okay. Is there anything else I wanted to do? Well, I wanted to check how many places do you repeat this. 7 places. 1, 2, 3, 4. So that is one we can probably get rid of. That one, not so much. 5. And that's just tests. Ah, man, this is really nasty though, because like it's so easy to mistype this. So if the but also it'd be nice. Well, yeah, we need to enable these asserts somehow. And it'd be nice to just loop over this for index is 0, index is less than solution types length. Solutions index is something, right? Pragma message solution types index string of. Cannot be read at compile time. Well, static, like for each. Type index. String of. Okay, well, this is getting somewhere. Can we like yeah, we can combine strings together inside a pragma. Okay, so what I want is to just kind of call it with the appropriate input, and then arena and scratch. So that. But also it needs to be like solutions type index equals. Actually, it's solutions type index. It's like that. Oh my god. Alright, well, yeah, this is getting somewhere. Solutions 0, solutions 1, solutions 2. It's almost what we wanted. The only thing I need to figure out is input, which I guess it's just called global input. So if we go to input and we just make this name match the type name, then we could just write global input and we just write the type name again. String type. Yeah, nah, let's just copy paste that. global input year 2022 day 1. Okay, well now they are synchronized automatically. Although, alright, so let's scope this. Let's pull out type name, like const string. Does it have to be a const string? String type name. Const. Yeah, it has to be a const string. Type name, and I also want to, first I want to create a variable that's just like type name solution space. Okay, so solution equals that, and then oh god, and then we can just write solutions equals solution. That. Okay, and right here we can put these asserts. Okay, is there a static switch? I wonder. Static if type in, well actually it's not even type index, right? It's type name, really, what we care about. Static if type name is year 2022 day 1, something like this. Oh god. Then put these asserts in there. Okay. This solution. So something like this is what we want. And instead of pragma message, this is a mixin. Yeah, something like that. Of course, every one of these functions would need to take the same inputs now. Ref arena, ref arena scratch. Okay. So can we like look at the expanded version of a static for each? dlang expand. You can look at the expanded version of mixins. Static for each. For each. How about a static for each? Well, there is one. Now. Yeah, but like. To expand that, okay, let's read the bmd help temp Nixon. Yeah, so you can expand Nixons. Is that gonna help? Nixon Nixons.txt. Nixons.txt. That is a lot of them. Year 2022. Yeah, so it only really expands yeah, it's not enough. Just do your conditional compilation and then like print out all these code blocks is what I want. Actually, do we need to keep the arena and scratch around? Maybe not. Well, we might use those in UI, but I don't think we're using them in UI now. Or are we? Oh, we are. Well, we're using Scratch anyway. And we could pass it in here. Yeah, these things we definitely do need to keep. Oh, well, I mean, we could pass them in as well, I suppose. Okay, does this run? Yes. It runs. Okay, let's see what we've done. Created the state. Yeah, you know, maybe just put that into the destructor. Destroy. Maybe just do this. And then I don't have to write this. Presumably it will run, right? Yes. No matter where we are exited out of the scope, it should run. Which is what we want. Okay. active solution, buttons. Well, actually, button iteration is elsewhere. This is drawing. Yes, all of this is just drawing stuff. This is essentially the update, and this is the render. And all of the update happens in this platform-specific manner. And here we only have the render. Some type. Yeah, even view context. Maybe just pass that in. Yeah, this makes more sense. Okay. Oh, so mixins and temp should. Wait, did I delete something I shouldn't have deleted? Yeah. Oh god. No, we don't want to delete this. Actually, we don't want to delete this. My god. Restore. Yeah. Mixins, though, we do want to delete. Yeah, this is fine. Yeah, that's fine. That's fine. Yeah. Put all of these into constructors. Create the state thing. Yeah, and this is just names. Name changes. Okay, so move non-platform specific stuff to the main file. Okay. It was not deleted. Hopefully. Yeah, it's not deleted. Alright. Alright, so there's our histogram. what did I want to do with it? Multiple things. Multiple things, one of which was to draw an actual scale so that it's not just rectangles floating around. Okay, that's not here. Yeah, so this part. Function literal. Alright. Result string followed by... Can layout row, by the way, can layout row not take this? Like, is this something that we can do? Yes. Okay, good. So there's our result graph. Okay, a lot of things are happening here. One of which we need to know the width of the graph before we do anything. Okay, well, so how would we draw the scale? Solution result graph is here, right? So if we were to draw the scale, that would be a vertical line with ticks on it. So, well, that needs its own rectangle. So, hello chatter. So need to move. What is D language? Well, I mean, you kind of answered it. It's a programming language. It is called D, like C. It means I visualize the problem, yeah. I'm drawing a histogram for the first day right now. Okay, can we move the rectangle? Bounds x plus $50, bounds width minus 50. So, okay. Now we can just keep using the bounds. Okay, so for some reason the scale is now all messed up. But it did move by 50 pixels. Really? Why? Oh wait, it's because I need to do the layout row before doing new layout next. Like that. which would mean that the scale would scroll away as you're scrolling the histogram, which is like, maybe that's not what we want. So another panel? Do I need another panel? I need another panel for the scale specifically. Which means that when I lay out this row, it's not total width. It's not total width. It's, well, this still happens, but it happens here. $50 is the width. And actually this is just the scale. Actually, how does this work? So you lay out a row, then you begin a panel within that. Okay, well, let's try it. Scale. And unidentified identifier. Okay, well, yeah, I don't know what that's gonna do. Interesting. Well, we created something here. It looks like a panel. So lay out a row that's the size of the parent, and begin a panel within that, then lay out a row of width 50, begin a panel within that. Actually, what if I lay out 2 rows here and then begin a panel begin panel, end panel, then you lay out, then you skip this layout and you kind of begin panel again. Plot area and your end panel. Okay, so that's what happens. Okay, so the rows do go before the panels. Actually, what do I do here? So in here, I lay out a row. Actually, what? Alright, so there we go. So I laid out a row with 200, width 200 and minus 1. So 200 and then the rest of the available space. And then I do begin panel, layout row within that, end panel, begin panel. Okay, now we just need to do that again. Layout, okay, so this is the result string that's at the top. Is that still working correctly? So that's still working correctly. Yeah, okay, so solution result graph. Well, solution result graph, let's say we want it to be two panels next to each other, something like this. Then you begin panel, and you lay out a row again for the scale. Let's comment that out. So this begin panel terminates here. Yeah. Alright. Well, no frame isn't helping. Let's put the frames back. Ah, I see. So they're going inside of each other there. So solution result graph, and then scale is inside of that. So the scale would go in here. Okay, that's not great, because then the scale could be desynced from the graph, because that's probably not what we want. Although, maybe it is. So what if I do 0 here and 0 here? Is it going to be the same as the parent? No. I'm guessing -0 isn't really a thing. I mean, we could get the parent. We could get the parent dimensions and just fit it within that. Okay, so what is exactly? It's like a -1, 1. Okay, well, hold on. Layout row 200 -1 -1. So this is the first row. The whole screen is the first row. This is the 200 part. And this is the -1 part. And the height is also -1, so it's the parent -1 pixel. Okay. So the first panel, the selector thing, goes in to the first column of the first row. And inside of that, I lay out one row, full width, 20 height. That's where these things go. And then that's where the buttons go. Then this panel goes into the second column of the first row. Yeah. Then within that, okay, so within that I lay out one row, full width, and just font height ×2. Then I change the layout to 2 rows. Well, then I begin the panel within that. So I panel this out. such that it scrolls independently. Then I switch the row layout to have 2 rows, 100 minus 1, so there's the 100 part. Then begin another panel within that, and inside of that panel, and that's what we see. We see this panel and this panel. Okay. So then this part, total width, actually it's not quite right, because so this panel, the solution result graph, that should presumably contain the whole graph, although as is it isn't really doing that. Like if I lay it out this way, then what I want probably is this. So there's the 2 rows. Begin a panel within the first row. So that's this 100, but it's where the panel should start. Mute row rect. Red. Yes, so the next panel this is how I've been doing it. So the next panel histogram scale. Okay, so the next panel should presumably go into the second column. Need that. Okay, so let's just do that. Well, okay, so it's a little too bright. Well, they do seem to be aligned. Actually, let's check if they're aligned or not. Yes. Well, as long as the scale and the plot area are aligned, they can reside in different panels, and that shouldn't be a problem. So let's, yeah, so this part can probably be the same. Yeah, so now the histogram is scrolling, but what's meant to be the scale isn't. Yeah, that works. Well, we kind of know that this is the scale because of that. Oh yeah, I wanted to remove the is it mu ops no frame. I don't know. The scroll bar. The scroll bar actually shifts it up because it's part of the overall. Oh. Yeah. That is a problem. I mean, we can access the height of the scroll bar. So that's at least not an issue. Although, can we force where is this? Well, you can do no scroll. Well, you can do no scroll, but you can't really force there to be a scroll bar. That doesn't need to be there. Okay, well, hold on. Is there... where's the size of the scroll bar? Scroll bar... Scroll bar size. Context style scroll bar size. There might be biting around it though, so it might not be 12 necessarily. And then if it's not scrolling, its height will change. Actually, there's nothing really... well... it's not like we have to fill this rect right away. So we could just begin this panel, do the layout, get the bounds. but then draw them later, like here. And at this point you could do scale bounds height equals bounds. Did it get clipped out, or what happened there? Yeah, it probably is getting clipped out. Let's see if I draw it here. Yeah, then it appears, but if not, then it doesn't. Hold on, what if I end panel beforehand? Yeah, it appears, yeah. Okay, so this is like janky as all hell, but I mean, you do what you gotta do. So we end panel to remove the clip rect. Then we adjust the bounds, and then we draw the rect. And now they're aligned. Well, yeah, I mean, that works. Of course, there is going to be this gap between them. But maybe that's not such a big issue, and maybe we can even solve that. Alright. So now they're aligned, and they should be aligned, even if we don't have the scroll bar, which you can probably verify, you know, somehow. Total width, yeah, like here, no scroll bar, still aligned. Scroll bar aligned, yeah. Oh, okay. It's not, doesn't it? Okay. So instead of drawing the rect here, I need to draw a line. That's probably, that's sort of at the rightmost edge. So mu draw rect, mu rect v line rect is scale bounds. So the x should be moved by width minus v line rect width. V line rect width is 2 pixels. And we move the x to the right, and yeah, let's see, where does this land it? Okay, but still, I mean, I'm not using it. That lands it here. That's fine, that's kind of where we want it to be. happens with ticks if we just draw some int tick start at 0, tick less than let's say 100,000, tick plus equals 1,000. I mean 10,000 though, probably should be 100,000. And let's go in steps of 10,000. I mean, I do kind of want to know where this v-line rect is. So, okay, so these are the actual tick value scale. So let's stick on the value scale, and we have a way to scale things. Actually, can we just define like a local function here that just scales from one to the other? Like the scale function is general one. Int this scale, I guess value scale or something. Int val. And we'll just call that. Actually, can we do one liner? Wow. And then just call value scale on the sum. Is that possible? Yes. And we can use that value scale here. Oh, I mean, it's 2 scale 2 pixels. Tick value scale. I'll just call it tick value. Int tick pixels. There. So mu rect tick rect is v-line rect. Let's say x is, well, actually x is the same. Well, I mean x, I need to fatten it. -5. Height needs to be reduced. Width is, well, let's say 10. Y is that tick pixel. Mu draw rect mu context tick rect mu color yellow. Okay, so what's that gonna do? Okay, well, it did something. They're moving to the right progressively, and one of them is drawn on top of the line, so no, because I'm changing v-line rect, not tick rect. Well, okay. Okay, well, that's kind of what I wanted. So is 0 clipped out or something? Like the first one's way down here, which is a little strange. One, two, three, four, five, six, 7. Okay. What's the first one? Take pixels as 0. Oh, yeah. So that scale to pixels is actually not scale to pixels, because it scales to, I mean, it's scaled to pixels, but it doesn't really account for the offset. Yeah, so the original is from 0 to max sums, and the new is from 0 to bounds height. Okay, so it's actually, it's upside down. Okay, so this scale to pixels. Maybe we need to change how that works, because that's too confusing. I need to do something like, okay, we're scaling from here to here, and the minimum value is actually bounds y plus bounds height, and the maximum value is bounds y. So now this is not the height, this is actually hystract y. Okay, so what is this? Bounds xy plus, well, no, it's these are actually top down. Yeah, so bounds xy, width 10, height 0. So hystract y becomes that, and hystract height becomes the difference between bounds y and hystract y. Okay, so I think it's that. Let's find out. No, it's not that. Well, let's see. Hystract. I should probably step in here. Okay, so it's 323, 51, 10. Okay, what are bounds? 350, 351, 3000, 1000. So hystract y becomes 222, which is so this y is 51, the height is 1000, so way down here. So this is not far from 51 down. So bounds y, actually it's not bounds y, it's bounds y plus bounds height, so like the minimum value, minus hystract y. I think that should do it. Yeah, so there they are. Okay, so now the ticks are correct, because they are actually being scaled to the pixels. And if the first one is apparently close to what, 0, 1, 2, 3, 4, 5, 6, 60,000. Yeah, it is. Alright. Okay, so that seems to be working out. So we have ticks. So whichever color we have for the histogram, I guess we can just use the same color for everything else. New color, his color. That's V-line. It's histogram. Yeah. Like I said, this does clip out though. Now another thing I want to check is what happens if I try to draw a grid behind the histogram rects. We know where to draw it, right? Well, actually no, not there. I mean, while I'm drawing the ticks, I might as well continue the ticks. Actually, what happens if I do continue them? Do they continue? Oh, they do continue. Except I want them to be behind the histogram, not in front of the histogram. And this top one is questionable. Oh, because the clip rect's gone now. It's like I want to draw this first because I want to know if there's a scroll bar or not. But I also want to draw this first. Because I want these lines to be behind. Okay. The ever-present problem in UI, which you draw first? When everything is interconnected like that, which you draw first? Okay, so we know that they do continue. I mean, I guess you can do two passes, right? Where you lay it out, then you lay out something else, then you go back to the first thing and like fix it. I mean, ideally, it would just be correct the first time. Yeah, there is that tick at the top there. I mean, I guess we could just set the clip rect ourselves and just kind of use it. Yeah, how do we do that? Okay, so mu layout next is one of the functions that's available to us. Mu layout. There is a set clip, right? Okay, so there is a set clip. Okay, now we just need to figure out where do we want the clip to be? I guess we want it to be just within this. So we end this panel, but then scale bounds, right? new set clip. New context, and what is this? And direct scale bounds. Alright. So that's where it clips out. I see. I mean that works for me. Of course, if we try to draw something else elsewhere, is it going to undo that clip for me, or is it just going to be there forever? Because we kind of set the clip, and then is there like a push clip or clip stack? There's a stack of clips. Push clip rect. There we go. That's what really we want to do, probably. New pop clip rect. Okay, it still works. And this is the last thing we're drawing, so you're not gonna see the effect of it, I suppose. Unless I try to draw some rect somewhere. Like here. So if I draw it before popping in the clip rect, bounds. Okay, we're not modifying the bounds, right? Yeah. Okay, so it's not. What is going on there? Okay, so I'm drawing it before popping the clip rect. So it should be clipped out, but it isn't. I mean, it kind of. Well, no, it is clipped to this area, so it's correct, and that's. But why is it not here now? What if I draw it after? What do we get then? Well, oh, the direct itself is changing position. That's what's happening. I see. Okay, so pushing and popping the clip rect seems to work. That's the whole point of this exercise. Grid line. Grid line. I mean, I guess like, we know what ticks we're gonna be drawing, right? So just before drawing the histogram, we could just draw the ticks. I mean, draw the grid line. What would that look like? age grid. Set it to bounds. So these are the what? The bounds of the actual rectangle. Okay, so the x isn't going to change, and the width is also not going to change. Yeah, it's the height and the y that changes. Okay, so those are, yeah, that seems about right. Of course, they aren't connecting. They aren't connecting here, so presumably because they clipped out, right? We have a clip rect. That's preventing them from connecting. That's not ideal. Ideally, they would just connect. Of course, we could just remove the clip rect, right? Draw these things, and then put the clip rect back on. Again, not ideal, but I mean, probably better than what we have. Let's change the color just to make sure they're drawn behind. R, G, E, A. Plus 19, why not? Yeah, they are drawn behind. I mean, the 0 one is kind of not necessary. And also, should probably just well, I mean, these need to be synchronized with the ticks, unless we also want to draw the ticks here. Age Greek. Yeah, I mean, I guess we could just like we know what the bounds are for the rectangles. These bounds. Rect bounds. We know what the bounds are for the scale, and rect bounds don't change. And which you can just do scale bounds h is rect bounds h. And then just draw the scale, right, without having to do this twice. so we don't need to do that. We need to define this function, right? Then draw the scale. Then draw the rects. So push clip rect. So the clip rect is just going to be sort of like scale bounds plus rect bounds. So we basically want to extend rect bounds. Mu rect. Like scale and rect bounds. Mu rect. So x is going to be scale bounds x, y is going to be scale bounds y, width is going to be rect bounds x plus rect bounds width minus scale bounds x, and height is rect bounds y plus rect bounds height. Well, they have the same height actually, don't they? So just rect bounds height or whatever, scale bounds. So it's scale bounds, but we stretch it out to the right there. Then we push this clip rect. And then we presumably draw the thing. Actually, you can't. It intersects them, right? When you push a clip rect, it intersects what you already have. So you can't expand it really. So when you pop a clip rect, does it give you the clip rect? No. But we could access them. Yeah. So context clip stack. So there's just a clip stack. It's hanging out. So we can just access that. And what does pop do? Oh dear God. Stack.index, stack index minus minus. Yeah, this is just the assert. So really it's just stack.index idx minus minus. Okay, well, what if I just mu pop clip rect? What if I just remove a clip rect, like, and replace it essentially with this, and then so we remove the existing one, push a new one, do the drawing, and then push the other one back on. So this is just going to be like rect bounds, right? Although maybe not. Okay. What if this is 1,000? Okay, so this is kind of working. Well, I mean, not quite, because clearly we can see the consequence of messing around with clip rects. Although it is kind of strange that it does that. Because rect bounds should presumably, well, let's see what they are. Rect bounds. 353 on the X there, whereas scale on rect bounds are 219. Hold on, what if I mu rect bounds X, rect bounds Y, width, height, well, it's clipping to that, presumably, right? Rect bounds height. Okay, well, this does seem to be correct. Like, it's clipping up to here. Well, actually, yeah, rect bounds it's not accounting. Okay, I see. So I think we actually need to access the thing that we popped here. Mu rect rect clip rect is gonna be mu context clip stack mu context clip stack and mu context clip stack index. Oh, actually, there is a get clip rect. There is a get clip rect. So that, okay, well, that works pretty well. Okay, so this is there's probably a way to write this better, but you're gonna have to think about that. So width, I guess we just want it to be rect bounds width, like just go all the way to the end. Yeah, that seems to be going all the way to the end. Except that the color is I really need to decide on the colors. Well, for now, hist color, grid color, and like axis color. Okay, let's not like. Well, I mean, I guess these hundreds. Let's make them like 50, and axis. Actually, 50 would make it brighter than 150. No, that would make it 50, and this will be 150. Yes, so that would be grid color, and the V line will be axis color. Yeah, whatever that looks like. disappeared? I mean, we only see them here a little bit. Are they are they the same color as the background? Let's make them 125, slightly different. Yeah. So the background color of this in general seems kind of too bright. Where is the styling? Here. Text, border, window, background. Oh yeah, it is 50-50-50. But border is 25-25-25. We could just modify it right here, I suppose. Yeah, let's leave it. I mean, 50 for the background. It doesn't... And we can draw our own plot background, I guess. If it really comes to that. So that is 25 right there, that's the border. What if we do 25 for the grid? Interesting. Can we do 25 for the axis? What's that gonna look like? Like that. Yeah, that's not bad. Although it is a little strange how like the background's dark, but then to contrast with it, you make the things even darker. Like typically when you have, well, let's see, like here, you have dark background, and to contrast with it, you make things lighter. But that's not how the default style in micro UI works. Now you make things darker. Anyway, I can think about the styling of it. What was that flash? Sometimes there's this black rectangle flash. I don't know where it's coming from or how to reproduce it. Yeah, we don't really need anything at the bottom here, because yeah, that's 0 clearly. Numbers would help all along the ticks. And then probably sort the histogram to make it look nice. And well, we have the answers right at the top. Ideally these answers should be readable from the plot, at least approximately readable, which I guess if we sort the histogram, then you can read that number. Kind of, it's going to be one of these two. And well, you won't really be able to read that one, because you'd have to like sum the top 3 yourself, but it'll be somewhat visible. But also each histogram actually consists of multiple smaller counts, because this is a sum of multiple numbers. So if you could just split the histogram into multiple parts and draw each part separately, that would be a closer representation of what the data is. So we're gonna do that later, not now. What did we do? Remove the white space. Yeah, always good to do that. that row, and then there's a right. Draw a histogram grid. Alright, that's all I'm gonna do today. See you later.